Filament LED light bulb repair. This is the documentation of the experience of a hobby project, made with the hope that it could be helpful to others. But any comment that could help me to improve my practice is also welcome and appreciated. Unlike other videos in this series, this particular one shows an experimental fixing process, and there is no extra written documentation attached to it. Filament LED light bulbs have a tiny current regulator hiding inside the Edison screw socket, and in case of failure, that could be the culprit. This video shows an experiment to recover a light bulb that suddenly started to malfunction, but the repair could be as expensive as a new one. Therefore, this is not recommended, and it should remain just a fun project. Some thick electrical wire is used to fill the recess of the screw base. The central terminal of the screw base is removed using a thin tool. For safety reasons, the glass envelope is wrapped inside a small plastic bag. The Edison screw base is gently pressed inside a small vise, equally in all orientations. This with the purpose of breaking the glue that is keeping the glass envelope attached to it, hopefully without breaking the glass. Previously, some thick wire was wrapped on the screw base to avoid ruining the screw completely during this process. The base is now loose. It is now possible to desolder the wire that is connected to the Edison screw. The LED light bulb is connected to the small current regulation board with two thin wires that are wrapped on posts but not soldered. While unwrapping these two wires, it is a good idea to mark the LED string polarization according to the signs printed on the regulation board. The glass envelope has an evacuation pipe that is used for centering the small regulation board, which has a hole in the middle for this purpose. While using the vise on the screw base, the evacuation pipe broke, which allows to notice that it is made only for aesthetics, because even breaking the pipe, there is still no access to the inside of the glass envelope. The small board hosts the IC BP5116 for the current regulation, and its arrangement resembles the typical usage for this IC. Some tests are done with the LED filament using a high voltage power supply and a resistor in series of about 10 kilo ohms. By the way, this setup is very dangerous because there is high voltage all over the place. The LED string needs about 270 volts, and for this project, it seems safe to power it with about 8 milliamps only. The plan is to build a rudimentary power supply, assuming a maximum input voltage of 240 volts AC, which once rectified would provide a maximum of 340 volts DC. A small piece of prototyping board is cut round following the size of the original current regulation circuit. To obtain a value close to what was calculated, two resistors in parallel are used. 15 and 22 kiloohms, which would make about 8.9 kiloohms. Before the resistors, the rectifier diode is inserted. It is the usual type 1 in 4007. After the rectifier diode, it is necessary to put a smoothing capacitor, otherwise the light would be flickering. The same electrolytic capacitor used in the original current regulator circuit is recovered and installed in the new board. Powering the new rudimentary circuit using an isolation transformer and a dim bulb tester, it seems to be working well enough. The necessary wires and posts are added to the new board. An attempt to connect the LED filament light bulb to its posts without soldering them failed, so the two terminations are now soldered. The new circuit is inserted in the Edison screw and the external terminal is soldered. For now, the central terminal is left where it is. Before taking care of it, it is necessary to glue the Edison screw to the glass bulb. Super glue and baking soda are used for the purpose, considering that this is only a fun project. In fact, some residues of baking soda would remain inside the Edison screw, affecting the circuit as a corrosive agent. Therefore, this method is not recommended for a more serious project. As for the central terminal, it is sufficient to cut flush the corresponding wire and to insert the original button for making contact. The result looks okay, but there are important issues. First of all, the new rudimentary current regulation circuit is calculated for a too low current, and the light is very dimmed compared to the original emission. Secondly, the residues of baking soda that remained captured inside the Edison screw, which did not react with the super glue, may deteriorate the small circuit. Thirdly, but most importantly, this new rudimentary circuit does not include a fuse, which is always fundamental for basic safety. The next time that I try to recover a defective LED filament light bulb, I should consider calculating a higher current, and add a fuse or something that would operate like that for preventing fire hazards.